Hello everyone. Welcome to this online mathematics class. Today we are going to deal with how to find the number of divisors for a given number, and the second thing is how to find the sum of the divisors for a given number. Okay. So as you can see on the screen, so these are the two problems we are going to deal with that. Okay, find the number of divisors for a given number, and the second thing is find the sum of the divisors for a given number. Okay, to find this or this, we have one particular method. Okay, we follow that method to find the divisors, number of divisors or sum of the divisors. We have particular method for this one and for this one, so that we can easily find within a few steps the final answer, means the number of divisors for a given number and the sum of the divisors for a given number. See, finding a divisor, it is easy for a single digit or a two-digit number, right? Finding the divisors. For example, if I pick 6, if I am taking 6 here, what are the divisors? 1, 6, 3, 2. Divisors in the sense these are the only number where this particular 6 can be divided. So 2 3s are 6, 3 2s are 6, 6 6 get cancels, and 6 1s are 6. Okay, so these are the divisors of 6. We can easily find this one. When it comes for the bigger number, for example, if I take 10672 or 630 or 9504, if you want to find the divisors for this number and this number, it is very difficult for us to find the divisors. Or in other way, I can tell that it will take more time to find the divisors. In order to find the number of divisors or sum of the divisors, this is nothing but the number of divisors in the sense how many number of divisors are there. Number of divisors of 6. Only the thing is you have to count 1, 2, 3, 4. This is nothing but the number of divisors. Sum of the divisors in the sense sum of the divisors of 6 is equal to, we need to add this one, that is 1 plus 6 plus 3 plus 2. If you add this one, that will be 6, it will be 12. So this is the story, that is sum of the divisor is nothing but you should add the divisors, and number of divisors means how many divisors are there. This is 1, 2, 3 and 4. Okay, that is the story about this one. So it is very easy to find the number of divisors for a single digit. For example, I have shown to you here. Yeah, it was 4. And to find the sum of the divisors for a given number, like for same example, even I have found it. Sum of the divisor of 6 is equal to 12. I need to add the divisors here. It is very easy for a single digit number. When it comes to bigger number, something like this, where we need to find the sum of the divisors and number of divisors and the sum of the divisors, it's very difficult me to get this one, or in other way I can tell you that it will take more time. So in order to get the number of divisors for this or this, and also sum of the divisors for this and this and this, we have one particular method where we can actually find the number of divisors and sum of the divisors for a composite number. Okay, we have that one particular method. So let's get started with the example. I'll pick one example. There you'll come to know the each steps how I have to do, and in the same way you are supposed to do the example problems also. Okay, let's get started with the first example over here. So as you see on the screen, the first example, that is find the number of divisors of 3240. In the first step you are supposed to take the LCM 0, and this is we'll start up with the 2 here. Okay, 2 ones are 2, and one number goes here. It is like now it is 12, so 2 6 are 12, so 2 2s are 4, 2 and 0, 2 zeros are 0, and again I'll take 2 because it is possible, it will go. So 2 8s are 16, 2 1s are 2, 2 zeros are 0. Again from 2 it is possible, so 2 4s are 8, 2 5s are 10. So 2 okay, 2 40s are 80, 1 carries here, 2 5s are 10. Yeah, okay. So from 2 it is not possible because 2 2s are 4. Okay, 2 2s are 4, 2, I'll write it here, 2, I'll write over here something like this, it is there. Okay, 2 2s are 4, 2 20s are 40, and 2 5 is there, so it is not possible with the 2. So let me take the next prime number after 2, which is the prime number 3. So in order you should take, first you'll see for 2 prime number, then you'll go with the next prime number 3. Again if it is 3 is not possible, again from 3 it is not possible, then you should move on to the next prime number, that is 5. Okay, so let me check with 3. Okay, 3 ones are 3, 1 carries here, it will be like 10 now. So 3 3s are 9, again 1 carry over here, so 15 it is. So 3 it will go in 3 it will go, right? 3 3s are 9, 3 4s are 12, 3 5s are 15, so it will go. So let me pick for 3 again. So 3 4s are 12, 3 4s are 12 means 1 carry over here, so it will be like 15 now. So 3 5s are 15 again, so I'll again go with the 3. So 3 1s are 3, 1, so it will like 15 here, 3 5s are 15. So again I'll take for 3, 3 5s are 15, so 5 1s are 5. Okay, so this is a pattern of numbers, that is 2 2 2 3 3 3 3 5. Okay, this pattern of numbers I'll arrange in this order. So let me take, let n is equal to 3240, I'll write over here, which is equal to what? How I can represent these numbers, like 2 into 2 into, how many 2s? 2 into, so I'll write down because there is no place, so otherwise it will be confusion for you. So 2 into 2 into 2, 1 2 3, so 1 2 3 into 1 2 3 4, 3 into 3 into 3 into 2 3 4. Okay, 3 into 5, 1, no need to write it down. So I have written the pattern of numbers, pattern of prime numbers, what I have got from this. So I have written here. The next step, which is equal to 2 to the power, how many times it is there? 1 2 3, so 2 power 3, right? I can write down in this way, right? Again 3, how many times it is there? Into 3 power 1 2 3 4, 4 times into, what is the last number? Last number is 5, so how many times? Only 1 time. Okay, so that implies n is equal to this. n has been expressed in the standard form. So n can be expressed in the standard form, I mean it has been expressed. So n has been expressed in the standard form p1 k power 1 into p2 k power 2 so and so up to pr kr. This is very important. See, n has been already expressed in this form where p is nothing but the prime numbers and k is nothing but its power. Okay, so it has been expressed in this. Here, what is p1? By comparing this one, you just tell me what is p2, what is p3. How many prime numbers are there? 1 2 3. So I have taken p1, p2, p3. Suppose 4 are there, you can take p4. 5 are there, then you can take p5. Okay, so accordingly, how many k's are there? How many powers are there? k1, k2, k3. So k1, k2, k3. Okay, so now tell me what is p1? P1 is 2. What is p2? 3. What is p3? It is 5. What is k1? K1 is 3. What is k2? K2 is 4. What is k3? K3 is 1. So I have written this. Therefore d of n, this is how we are supposed to denote the number of divisors of a given number. The number of divisors of n, right, of n, which is equal to n, which is equal to 3240, right? This is equal to, this is like a formula you are supposed to remember. k1 plus of 1, k2 plus of 1, k3 plus of 1. Since only k up to k3 is there, so you are supposed to write. Suppose k4 is there, then you can write k4 plus 1, so and so and so. So it is equal to, what is k1? It is 3 plus 1, k2 is 4, 4 plus 1, k3 is 1, 1 plus 1. If you solve this one, it will be like 3 plus 1 is 4, 4 plus 1 is 5, 1 plus 1 is 2. So if you multiply this one, no sign means multiplication sign, right? So it will be like 40. 5 2s are 10, 10 4s are 40. So that implies d of n is equal to this. That implies d of n is equal to 40. That I'll write in this particular box so that you can see the answer. So how I have taken the problem, how I have started the problem, you can see here. First step is n is equal to 3240 you'll write. Then you'll take the LCM and all these prime numbers you just listed out over here. You should begin with 2, because 2 is the first prime number. If it is not possible with 2, then you can go for the 3. If it is not possible with 3, you can go for 5. Similarly, the next prime number after 5 is 7. Where you are supposed to take the values, and you just list out all these prime numbers in this way. Then you can write down the how many times that particular prime number is there. For example, 2 here and the 3 here and the 5, so that accordingly can write its powers. So this is like a sentence, you have to write it down. N has been expressed in the standard form. N already I have expressed in the standard form, where p1 p2 k1 k1 k2 k3, all these particular values are something like this. If we compare this one with this, therefore d of n, that is nothing but, we actually denotes this as the number of divisors for the given number. This is like a formula you are supposed to remember, that is d of n is equal to k1 plus 1, 2 plus 1, k3 plus 1. Since up to k3 only is there, so suppose k4 value is here, then you can write k4 plus 1. Suppose k5 is there, then you can write k5 plus 1 up to, if suppose k10 is there, then you can you should write up to k10 plus 1. So that that simple thing you should remember. So only the thing is, you are substituting the values and you are finding the answer, that is d of n is equal to 40. What is the meaning of this? This is nothing but number of divisors. This is like number of divisors. How you have seen here 6 slide, how many divisors are there? 1 2 3 4, right? This is nothing but d of n is equal to 4 for 6. okay, for this particular problem. In the same way, we have divisors here. We don't know what are the divisors actually, but we can actually find that how many are there in number of divisors of this particular number, like 40 are there itself. Okay, but the numbers we don't know, but if we count it will be like 40. That is the problem. It's simple, right? That's it. It is very important. Please mark. It's very important, and they even they ask for 2 marks, sometimes or 4, I don't know actually, but I have seen usually for 2 marks only. So this is like find the number of divisors for a number. Usually this method is for composite number only. In exam also they'll usually ask for composite number only. Okay, so let us move on to the next one. See, first one we have finished with one example. First one we have done with one particular example. Next we'll move on to this, find the sum of the divisors for the given number. That same 6 example take here. These are the divisors, right? So if sum of the divisors, in the sense you just add it down, 1 plus 6 plus 3 plus 2, it is like 12. In the same way, for the bigger number it's very difficult to find, so we have one particular method, even that is very simple, you can follow that. So as you can see on the screen, I have written the example number 2. See, example number 2 is the question is different here. Find the sum of the divisors. This is very important. Sum of the divisors for the given number 360. So in this also you should know the proper method, and this method you have to remember for the sum of the divisors. And that for example 1 which I have done just now, that particular method you have to remember for the number of divisors. See, instead of sum, there it is just a number of divisors. And for this particular problem we have one particular method. So first 1 or 2 steps are same, only the thing is formula is different here. So let me start up with this. So let me write down n is equal to, what is n here, what is the number, 360, which is equal to, let me take the LCM over here. Okay, 2 ones are 2, so 1 is the number. I'll write it over here. So now it will be like 16 now. Okay, 16. So 2 8s are 16 and 2 zeros are 0. Again I'll check with the same prime number, that is 2. 2 9s are 18 and 2 zeros are 0. Okay, again I'll pick with the 2 number only, 2 as a prime number. 2 4s are 8. Yeah, it is possible. 8 means it is 9, so one number will come over here, so now it will be like 10. So 2 5s are 10. So again I'll check with 2, it is possible. 2 2s are 4, it is possible. 5, it is left as it is, so we have to go with the next prime number, that is 3. So 3 1s are 3. Since it is 4, one number come over here, so it is like 15 now. 3 5s are 15. Yeah, done. So again it is possible with 3. 3 5s are 15. 3 5s are 15. So now it is 5 1s are 5. Okay, so I can list all these particular prime numbers over here as how many times, 1 2 3, so 3 times, and 3 2 times. 5 is just 1 time, no need to write 1, leave as it is. Now the second step is this prime number with its power. So how many are there? So 2 1 2 3, 3 times into 3 to the, okay, 5 is 1 time. So I'll write the same sentence how I written for the previous problem. N has been expressed in the standard form, that is p1 power k1 into p2 power k2 up to so and so pk, oh sorry, p, you can take pk, no pr to the power kr. Okay, here here. What is P1? What is P2? What is P3? What is K1? What is K2? What is K3? So if you compare this one with this, so tell me, P1 is what? 2, and the power K1 is what? 3. Similarly, P2 is 3, K2 is 2. So, P3 is 5 and K3 is 1. Okay, since here also in this problem also we have only 3 prime number, that is P1, P2, P3, and its power, that is K1, K2, K3. If suppose any other prime number is there, suppose here 7 is there, then in here it will be P4 and its power is K4. Okay, in that way you are supposed to write down. Therefore, what we need to find sum of the divisors here. So this formula you have to remember, that is S of n. S of n, the meaning is sum of the divisors of n. What is that n? 360. Okay, which is equal to, this is the formula you have to remember, P1 power K1 plus 1 minus 1 whole divided by P1 minus 1 into P2 power K2 plus 1 minus 1 whole divided by P2 minus 1. This is very important since power is there and this plus minus 1. Sometimes what happens means you just write it on P1 and a minus 1 over here. So that is like a little bit confusion. Only by the practice you'll write perfectly. So make a practice of this formula properly. Okay, try to solve more problems regarding that so that you'll remember all those things. So this is a formula you have to remember for sum of the divisors of S of n, that is 360. So based on the formula I'll just write it down, the values here. What is P1? P1 is 2, so I'm writing 2 here. What is K1? K1 is 3. K1 is 3, I have written here. 3 plus 1 is here, and this minus 1 whole divided by, again P1 is 2 minus 1, and P2 is what? P2 is 3. K2 is what? 2. So 2 plus 1 minus 1 divided by 3 minus 1. And P3 is what again? P3 is 5. And what is K3? K3 is 1. So 1 plus 1 minus 1. This I have written here. P3 is 5 minus the 1. Now only the thing is you have to simplify this. This is 2. 3 plus 1 is 4 minus 1. 2 minus 1 is 1 and 3, and 2 plus 1 is what? 3 minus 1. 3 minus 1 is 2 and 5. 1 plus 1 is 2 minus 1 whole divided by 5 minus 1 is 4. Further simplify. So 2 to the power 4 is what? 2 to the power 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 minus 1, this minus 1 I have written here. So divided by 1, no need to write it down since it is 1. I'll keep as it is. So 3 into 3 into 3. 3 3s are 9, 9 3s are 27. 27 minus 1 whole divided by 2. So 5 power 2 means 25. Minus 1 I'll keep as it is, 4. So further you can simplify. This is 15 into, since no sign is here in the sense it is like multiplication here. Okay, no sign means here this multiplication. So I have written here multiplication sign, or even you can put dot also, that is not an issue. So 27 minus 1 is 26. Okay, 26 divided by 2. So 26 divided by 2 is 2 1s are 2, 2 3s are 6. So it is like 13 into 25 minus 1 is what? 24. 24 and divided by 4 is there. 4 1s are 4, 4 4 2s are 8, 4 4 3s are 12, 4 4s are 6, 4 5s are 10, 4 6s are 24. Okay, so I'll write straight away here. If you multiply this, if you multiply all these things, use your calculator and check, it will be 1170. So that implies S of n is equal to 1170. Means sum of the divisors for 360 is 1170. Means I have shown to you the 6 example 6. I'll turn the page and 6. Sum of the divisors of 6 is, the divisor will list out and we'll just add it down and we'll get 12, right? In the same way, we don't know what actually divisors of this particular number are. Okay, what actually the divisors we don't know, but if we sum that particular divisors, that value will be 1170. That is the final answer. So remember, this is find the number of divisors. This is very important. Find the number of divisors, then you are supposed to use this formula. Okay, this particular formula. Okay, all these things, it is same in that case also. And this second one, yeah, sum of the divisors, for this one, this is the particular formula you have to remember. Okay, since up to this you remember, up to P3 it is there. If suppose P4 is there, P5, then you can increase this also. Okay, not that is that only this terms you have to use. That is very important. Got it? So in the last paper, that is 2019, they have asked this particular problem, the same question, that is 360 for 2 marks. So it is very important. Both the problems are very important. The numbers they can change, but the procedure is same. Okay, you can see the homework here I have given to you. Okay, it is a home assignment. Please try to do this for 2 problems. The first problem you can see here, find the number of divisors and sum of the divisors. Both the problems I have clubbed here.